Yeah, hi everyone, Mr. Markwick here. In this video, I'm going to show you how to add and subtract surds. I'm going to go through a few key ideas here and then get into some examples. So first of all, in order to add and subtract surds, we're looking for like surds. So what are like surds? Well, they're multiples of the same surd. So there's some examples here. The square root of 3 and minus 5 root 3 are considered like surds because they have the same number under the square root sign, which is the 3. The square root of 12, although the 3 is not there, it can be simplified, or square root of 12 can be simplified to 2 root 3. So then once we've simplified it, it will be a like surd. And I will go through an example of how to simplify surds, or you can go back and watch a previous video of mine on how to simplify surds. And 2 root 75 can be simplified to 10 root 3. Again, I'll go through an example about how to simplify those. So we're looking for like surds in order to add and subtract them, and it's important that we simplify all surds before we attempt to add and subtract. So if you don't know how to simplify surds, then it's a good idea to sort of go back and have a look at that video and do some questions before you jump into adding and subtracting surds. I compare adding and subtracting surds to adding and subtracting like terms. If you remember how to do that, or you've done that before, an example might be 5x, let's say take 3x. There's two terms here, and they're both considered like terms because they have the same variable, which is x. So I can collect these like terms. In this case, I'm going to subtract them because of the minus sign in between them. So I'm going to do 5x take 3x to give me one term, or to simplify it to one term. I'm simply going to do 5 take 3, so I do the number in front of those variables, or the coefficient. So in this case it's 5 take 3, which is 2, and then the variable stays the same, so it's 2x. So 5x take 3x is 2x. Now that's like terms, but if I was to substitute those variables out for a surd, for example root 2, it's the same process. 5 root 2 take 3 root 2. I just do the number in front, 5 take 3, which is 2, and then the root 2 stays the same. Okay, it's as simple as that. I'm going to get to some examples now, very similar to that first one, and then I'll show you how to add and subtract when we first need to simplify those surds first. But anyway, these two examples are pretty straightforward. I've got two surds here, 2 root 3 plus 4 root 3. All I'm going to do is do 2 plus 4, which is 6, and then the root 3 will stay the same. So my simplified version of 2 root 3 plus 4 root 3 is 6 root 3. Second example here, I have 4 surds, 2 pairs of like surds. So what I'm going to do is I'm going to underline those for you. 4 root 6 and minus 3 root 6 are like surds because they both have the square root of 6 there. And positive 3 root 2 and positive 2 root 2 are like surds, again because they have the same surd there with the 2 under the square root sign. So I'm going to basically just add those pairs together. So 4 root 6 take 3 root 6 is 1 root 6, or simply square root of 6. Hey, just like algebra, if it's a 1, the coefficient, we don't need to show that. And then I'm going to do positive 3 root 2 plus 2 root 2. Again, just adding the number in front of the surd, the 3 plus the 2 to give me 5. In this case, it's a positive 5. And the square root stays the same as root 2. Okay, so it's as simple as that, and that's a simplified version of this expression here. Okay, moving on. Like I said earlier, you need to be able to simplify surds before you can add and subtract them. Here I have 2 surds, which at the moment they're not like surds. I can't simplify the square root of 2 because there's no square factors of 2, but I can simplify the square root of 8. Once I do that, then I'll be able to add them together, or in this case, subtract. So 5 root 2 can't be simplified. so that stays the same. But minus root 8 can be simplified. I'm looking for a square factor of 8. Now, if you go back to my last video, you might have seen me using a factor chart where I find the number that I'm looking for. So in this case, it's 8. I'm looking for the square factors of 8. The highest square factor of 8 is 4. So the square root of 8 can also be written as the square root of 2 times the square root of 4. So that's how I'm going to write the square root of 8 there. I'm going to get rid of that. And I'm going to put in the square root of 4 times by the square root of 2. And the reason I put the square root of 4 first is because 4 is the square number, or 4 is the square factor. That can just be simplified to 2. The square root of 4, because 4 is a square number, can just be written as 2. So I'm left with now 5 root 2, take 2 times by the square root of 2. Okay, so the square root of 4 has been simplified to 2. Now, if I just get rid of that multiplication sign, so 5 root 2, take 2 root 2, I've got 2 surds here that are like surds. I'm just going to go through that process I did earlier, doing 5 take 2, which is 3, and keep that root 2 the same. Okay, so making sure that you simplify before you add and subtract those surds. This next one's a little bit trickier. It's got 3 surds there. I'm going to go through the process of trying to simplify them. The square root of 5 can't be simplified, or 2 root 5 can't be simplified. Again, 5 is a prime number, so there are no square factors there, so that stays the same. What I'm going to do is change colors here. So in red, I'm going to do this section. So minus 3 root 20 can be simplified, and I'm looking for square factors of 20. All right, so what are those square factors of 20? If I go to my factor chart, find 20, there it is, square factors of 20. There's only one there, it's 4. Okay, so the square root of 20 can be written as square root of 4 times by the square root of 5. So that's what I'm going to put down there. So take 3 times the square root of 4 times the square root of 5. Notice that number, the negative 3 stays at the front. Again, the minus 4 is at the front because that's the square factor. Sorry, the 4 is at the front because that's the square factor. And I can simplify that to a whole number. Then I'm also going to simplify this last surd, which is positive 6 root 45. Again, I'm looking for some square factors of 45. So if I go to my factor chart, 45, again, this time the highest square factor of 45 is 9. So the square root of 45 can also be written as square root of 5 times the square root of 9. Sorry guys. So plus 6 times the square root of 9 times the square root of 5. And the reason I put the 9 at the front again was because 9 is the square number, and the square root of 9 can be written as a whole number, which is 3. So now I'm going to go ahead and simplify this even further. So 2 root 5 stays the same. Minus 3 times square root of 4 times the square root of 5 can be written as minus 3 times 2 times the square root of 5, and positive 6 times the square root of 9 times the square root of 5 can be written as positive 6 times 3 times the square root of 5. Now I can go through and simplify this by multiplying these numbers here. So I'm going to keep the square root of 2 root 5 the same. Minus 3 times 2 is minus 6. So I'm left with minus 6 root 5. And positive 6 times 3 is 18. So plus 18 root 5. So now I have 3 surds here, all with like surd of square root of 5. So now I can simply just work left to right. 2, take 6, which is minus 4, plus 18, which is 14. And then the root 5 stays the same. So it's as simple as that, guys. Adding and subtracting surds, making sure that they're like surds, and making sure that we simplify them before we can add and subtract them. Okay, hope that helps, guys.